Hi, everyone, and welcome to this week's lecture. Today, we are going to be talking about bloodstain pattern analysis, or Chapter 13 in your textbook. So here are our learning objectives. As usual, you can use them as a study guide and just to gauge your understanding of all of the content that we're covering in this lecture today. So starting off with the theory and principles, the theory of bloodstain pattern analysis, or BPA, is pretty simple because blood as a fluid responds to forces in a predictable manner, right? So you apply a force to any type of object or blood that might have already come out of someone or something, then it's going to respond just like how we would expect per everything that you might have learned in physics. So the principles that we employ are pattern diversity, stain shape and vector correlation, and also physically altered blood stains, or PABs. So going into the pattern diversity principle, this says essentially that there are variations in combination of blood volumes and forces acting on those volumes, leading to recognizable classes of patterns, right? So we've classified all of these different types of patterns based off of what we see when we get to a crime scene. So then the stain shape and vector correlation principle states that the shape of a blood stain provides indicators as to the direction of deposition and the spatial origin of the blood. Sub-principles within that are impact, directional angle, and area of origin. So essentially, based off of the stain shape, we are able to then identify or determine where that blood stain originated from. Then the PAB principle states that exposed blood will react to environmental conditions in a predictable manner. So based off of the airflow, the humidity, the type of surface, then blood is going to dry or not dry, take on the shape of a very rough surface, or stay pretty solid and on a very flat surface. So these are just what we're observing when blood is interacting with its environment. So going into the methodology of BPA, you're going to familiarize yourself with the entire scene, just like with any other crime scene investigation. This is an addition into CSI. This is something extra that is done on scene to reconstruct the scene. You're going to identify discrete patterns and you're going to categorize these patterns. Then you're going to evaluate aspects of directionality and motion, points of convergence and area of origin, as well as evaluate interrelationships of stains and other items. Then you're going to define a best explanation given the data. So when it comes to that reconstruction, based off of everything that you're seeing, all of the reconstruction that you've done, all of the evaluations that you've done, what is the best explanation for how that bloodstain got there in that specific pattern? Then you're going to validate the conclusions through peer review. So jumping into directionality, so what we were talking about a little bit earlier, this defines the direction a droplet was moving at the time it struck a surface. So when we're looking at a blood stain, we can see or we can determine the angle of direction and where that blood stain originated from based off of the stain itself. So here we have the parent stain, which is essentially just the most whole looking stain in and of itself. So we have the parent stain, then we have the scallops coming off, and that gives you an idea of the direction that blood was traveling, as well as the satellite stains that are coming from the scallops. So because of the way that the blood fell as it was coming from that angle of direction this way, the parent stain up here is going to be relatively whole, but it's going to spatter and create those satellite stains. So then you can trace back the satellite stains to say, okay, this was all coming from this direction here. Okay. So then looking at a more elliptical stain, it's the same idea. We have our parent stain, and rather than having a bunch of scallops, we'll more than likely just have a tail and one satellite stain. So we follow that satellite stain and that tail back, and that tells you that your blood stain came from this direction. So looking into point of convergence, the point of convergence is where the reverse vectors of several related spatter stains converge on a surface. So like what I was talking about, the reverse vector is following the satellite stain up through the tail and up through the parent stain. So you're going in reverse. So then when we do that, we can see that there's an area where everything overlaps with each other. Now that area, that is called the point of convergence. And from the point of convergence, we can then evaluate the impact angle. So going into the impact angle, you'll likely remember this from the shooting reconstruction slides in the lecture from last week, but it's essentially the same concept. So we have our triangle or right triangle, we have our opposite, adjacent, and hypotenuse. When we take the inverse sine and we do opposite over hypotenuse or AB or over BC or a minor axis over a major axis, again, same principle as with shooting reconstruction, then we are able to calculate the impact angle. So looking at the ratio of width to length, take the inverse sine of our width and our length. And in this case, we have 5 millimeters as our width. Our length is 7 millimeters, so our inverse sine of that ratio is 45 degrees. So when someone was struck, we know that they were struck and the blood traveled at a 45-degree angle. So going into stain shape and impact angle, when a blood stain falls and at 90 degrees, you're going to see your parent stain, you're going to see scallops all around the parent stain, as well as those satellite stains coming off in every direction. So it looks relatively equal, even all the way around. Going into 70 degrees, so when our blood hits a surface at 70 degrees, you'll start to see those scallops are kind of curving in one direction. So we know that this side is where the parent stain is, and then where the scallops are a little bit more robust or taller, we know that this is the direction where our blood stain is coming from over here. Moving at 50 degrees, now we're seeing some scallops as well as those satellite stains. So we're able to follow those satellite stains up and determine that this is the area where our blood was, or the angle at which our blood came from over here. And then going into 10 degrees, we can see that our stain is now relatively elliptical, and we're seeing that tail and that satellite. So then we follow that reverse vector back up, and we know that our blood stain came from over here. And then with our measurements, then we can look at the width and the length to determine that this was 10 degrees. Same with our 50 degrees. We can look at the width of the parent stain and the length of the parent stain and determine that this was 50 degrees. So defining area of origin. So when you're looking at the area of origin, we're combining directionality, the point of convergence, like what we talked about, following multiple reverse vectors back to one spot, and impact angle for several stains leads to the area of origin for the pattern. So what we can see here in the figure is, let's say we're in a room, we have our blood stains on the floor, and we have a point of convergence here. When we then superimpose a right triangle in that area along that point of convergence, we're then going to be able to use our impact angle. So we've now determined the angle at which our bloodstain has traveled and follow that angle for each of these individual stains up. So we use a protractor to help us determine the angle at which that bloodstain impacted a surface. And then we can say, okay, well, they converge over here. So now we have our point of convergence, we have our impact angle, and then we have what we're looking for, right? So we have area of origin, point of convergence. This is defined by our impact angle, and this is defined by our directionality. And then we can actually calculate where the area of origin is. So based off of that, let's say that this specific length is 3 feet. Then we know that whoever was striking a person or another living thing, they had to be 3 feet or 3 feet or lower in height in order to get this specific area of origin. So we know that they were not at full standing height when this event happened. The victim could have been lying down, and so they were leaning over them. So it gives us an idea of reconstructing how high or the likelihoods of the distance at which this action could have been performed. So going into classifying bloodstains, they have to be based on specific criteria. The taxonomic approach does have 2 general categories. So we have spatter stains. So these are patterns made up of only small circles and ellipses. And then we have non-spatter stains. So these are stains that are not circles and ellipses, although circles and ellipses may be present. So starting with spatter stains first, we have linear spatter and nonlinear spatter. Expanding on linear spatter, we'll have arterial spurts, we'll have cast off, and we'll have drip trail. So these are linear because they're going to appear in like one fluid continuous motion, even if they might not specifically be linear themselves, like an arterial spurt. Going into nonlinear spatter, we have radiating spatter, and then we have drips. And radiating spatter can be expiration patterns as well as impact patterns. Then from impact patterns, we might also have mist patterns. So starting first with cast off, these are a series of related circles and ellipses in a linear or curvilinear orientation. They're consistent parallel directional angles. So the way that we might see cast off patterns is if someone might have been beating someone up with a bat or a blunt object, then cast off is when you might have some blood on the end of that bat and you swing it in one direction and the blood casts off in that direction. So then we can identify the direction at which that cast off could have come from based off of the scallops and the satellite stains. For our drip trail, these are a series of related circles and ellipses. Again, right, we're following the spatter stains in a linear curvilinear orientation. They lead from one point to another, and the impact angle is consistent with gravitational effect, so downward relative to the surface. So this is where, let's say I might be walking, I could have blood that's dripping down my arm, and as I'm walking or moving, it's just dripping from the point I started at, so the point I might have cut myself, to the point that maybe I got to a sink, maybe I got to bandages, what have you. So it's just identifying the direction of motion from one end to another. For a spurt pattern, these are, again, a series of related circles and ellipses, and a large volume is evident in the overall pattern or individual stains. This can include any of the following. We could see large elliptical stains, we could see line of stains or overlapping stains oriented in V's, arcs, or serpentine patterns. So this kind of goes into an arterial spurt. So an arterial spurt is when you cut an artery. And so with an artery, since it's moving such large volumes of blood, it's going to be expelling a lot more blood in a very forceful manner. So if you've ever seen someone have their throat cut open in a TV show or in a movie, it spurts out. And when it does that, it will sometimes spurt out in an S-shaped pattern. And you can kind of see that here. You see that S shape. And of course, the first part where it's spurting is going to be the most blood. So that's why we start to see it dripping down the wall. But then it becomes less and less blood that is expelled as more of the blood has already started to drip down the neck of a person, what have you. So we can see that there are those elliptical and those circle stains. And then you can kind of see some of those oriented V's here and here, and those serpentine patterns to like that S, right? Then going into impact spatter patterns, these are related small circles and ellipses with consistent directional angles radiating from a central point. The progressive change in shape of the stains there is a progressive change in the shape of the stains the further out you go from that central point. There are various size stains, but generally consistent throughout the pattern. So for impact spatter patterns, this is where we do a lot of area of origin determination. So I can look at a lot of these stains over here, and I can follow their satellite in this direction, follow in this direction, follow in this direction, follow in this direction, follow in this direction, and I will be able to say, okay, my area of or my point of convergence is here, calculate my impact angles, pull it out from where that was in 3D space, and there I can get my actual area of origin after I've done the point of convergence and the impact angle calculations. Because sometimes if we have a case like this where a hammer is hitting a surface, this surface could have been removed. So all I have are these satellite stains off to the side where I just see that elliptical shape with the satellites coming off of it, right? And the tail. So I'm able to say, okay, coming in this direction, coming from this direction, coming from this direction, the area of origin after I've determined the point of convergence and the impact angle is over here. So there had to have been a surface, someone could have cleaned something where this original impact occurred. So then going into mist patterns, again, related small circles and ellipses radiating from a central point, and it's evident from the dispersion of stains. So the majority of stains will be 0.1 millimeter or smaller, but larger stains can be present. So a mist pattern could be someone who is, especially you'll see it with gunshot wounds, where as something hits a body of like a person with a lot of force, a lot of velocity, it's going to create very small, misty type patterns. But you'll also potentially see impact patterns with gunshot wounds as well. Then we have drip patterns again, several small circles and ellipses deposited in a random orientation. So for a drip pattern, we're not seeing a drip trail. So we're not going from one place to another. This is just that random orientation. So we know that someone had to have been in that area for an extended period of time in order for all of those drips to occur. So here the impact angle is again consistent with gravitational effect downward to the relative surface. So if I'm standing, again, I'm going to be dripping straight down in that one area, and it's just going to be random wherever my hand was at that point in time. If again, I like cut my arm and I was bleeding from there. For an expectorate pattern, these are related nonlinear spatter patterns, and there's a wide range of size. So this typically is the presence of an airway injury or blood in an airway like your nose or mouth. And one of the following, there can be the presence of vacuoles and air bubbles or the presence of mucus strands. So this could be someone coughing, breathing out blood. So you'll see those air bubbles that are present. And then you can see the mucus strands that are connecting the bloodstains because bloodstains won't just have a strand that connects here to here. As we saw in the previous slide, when you're standing in one place, you just see those strips all together and there's nothing that's connecting them. So in order for them to connect together, we're going to be seeing those mucus strands, and that's what tells us that this is an expectorate pattern. You can also see the presence of epithelial cells, someone's coughing, right? Someone's sneezing, if there's an airway injury and all of that is coming out, you very likely, with all of that force, could see some of the skin cells. And then there's also the possible dilution of color because of the presence of saliva. So going into our non-spatter stains, we have irregular margin, regular margin, and pattern transfer non-spatter stains. And jumping into our irregular margin, we have blood into blood, we have a gush or splash, and we have smears. And then smears can be broken down into wipe patterns and swipe patterns. Then for our regular margins, we have flow, pool, and drip patterns. So going into our gush and splash, this is a non-spatter stain. It's got an irregular margin, right? We don't see one small circle or an elliptical stain. We see just kind of an odd shape. So we're seeing that irregular margin. And then it's exhibiting numerous spines that are coming out. This could also be accompanied by large elliptical stains. So as the gush or splash happens, then that's where we do see those large elliptical stains coming off. So like what we were talking about earlier, non-spatter stains very well could have circular and elliptical stains present, but they are non-spatter stains because we see that irregular margin present. So going into blood, this is a series of individual passive blood stains or a pooling of blood surrounded by a random distribution in both same shape and orientation of small spatter around the margin. So again, this is going to be someone that's in the same spot for a long period of time. It very well could have started as just drip pattern, but as blood started to accumulate, as that person or that organism stayed in that same place for an extended period of time, we're going to start to fill up that area. And as liquid is dripping into liquid, it's going to be spattering out on its own. So for a swipe pattern, this is a stain with a continuous boundary on one side and any of the following. You might see a feathered boundary. You could see striations in the body of the stain. You could see an accumulation of blood on the other boundaries and then a diminished volume of blood across the body of the stain. So here we can see that there is a diminished volume of blood across the body of the stain. You can see some striations within the body of the stain, and a swipe pattern is when, let's say I have blood on my hand and I touch a surface. So swipe is where I am depositing a movement onto a surface, as opposed to a wipe pattern where there is a pre-existing volume of blood and any of the following. displaced blood from the original boundary, the dried outer rings or skeleton of the original stain, and feathering, striations, and diminished volume. So again, pre-existing is a wipe pattern. So you can see that there is that dried outer ring or that skeleton of the original stain, because typically the first thing to dry in a blood stain is going to be the ring, and anything else that's smaller, because it's going to start pooling and coming together in the center, which is why it's still wet in the center and why it can be wiped. So then you'll see the feathering and the striations and the diminished volume as you pull that blood across a surface. So for blood flow, this is an accumulation of blood with generally regular margins leading from one point on a surface to another. So this is just blood flowing as gravity is acting on it. So if this person is laying down, you can see that, okay, the way that they were laying was in a way that the blood was coming down their arm. So they very well could have been sitting up rather than lying down on their back, because if they were lying down on their back, then you would likely see blood flowing in all directions, since that would be a 90-degree angle, but it's being pulled towards the ground. So they had to be standing up. And you can follow that kind of direction back up, similar to what we do with our impact stains. Follow up and then, originated here, and that's the direction and the angle at which the blood was flowing. So going into a blood pool, this is an accumulation of blood without any specific shape, but conforms to the surface contours. So it's going to essentially take into the shape of whatever it's pooling in. This may demonstrate serum separation, or the separation of blood cells from the plasma or clotting cells. So you can kind of see that it looks like there's some serum separation in this area of this blood pool here. But as the blood is absorbing into the carpet surface that you see, it's starting to spread out, right? So it's going to conform to the surface that it's on. So going into pattern transfers, this is contact pattern of blood. It demonstrates demarcations, curves, or other recognizable characteristics of an object. So this could be if someone beat someone up with a hammer and they lay the hammer down on a surface and you can see the shape of the body of a hammer, right? Here we have a footwear impression. So someone stepped in blood and is now transferring that pattern. And then we can further enhance like something like a footwear impression or even like a fingerprint impression with various techniques that we've talked about previously. And then we're able to document, take our photos and use those as comparison quality photographs to then do our evaluations of footwear impressions, fingerprints, and all of that jazz. So for complex patterns, although many patterns encountered will represent a single pattern type, like impact, not every pattern does. So crimes are very dynamic events, and this may result in what are referred to as complex patterns. So these are patterns that demonstrate several different characteristics and don't easily fit the standard pattern types. So when presented with these types of patterns, you're going to document them and identify what characteristics are present. So when it comes to documenting bloodstain patterns, it requires a lot of documentation in order for it to be useful, because you're, again, reconstructing the scene. You're trying to tell us what happened, where a perpetrator was standing, how long events could have been occurring for based off of like the blood pooling events and everything like that. So you're telling us what happened at the scene, essentially recreating the specific bloodletting events for the jury, for the other CSIs on scene, for the detectives. So you're going to take your standard overall photographs of the areas like the walls, the floors, showing all of the patterns. Then you're going to take overall photographs of the extent of each discrete pattern that you see. So again, crimes, very dynamic events. You might very well see an impact pattern next to an expectorate pattern. As if someone was beat with like a baseball bat, there could be a lot of blunt force trauma. You might see some impact from that blunt force trauma that's present on the scene. Person could have been coughing up if they were coughing up blood, so you're going to see expectorate patterns. And then as someone might be swinging that bat, you're going to potentially be seeing cast-off patterns. So you're always going to be seeing multiple types of bloodstain patterns present. So you have to make sure for each discrete pattern that you've identified, you're taking overall photographs of that pattern. You're then going to take detailed photographs of the extent of each discrete pattern, and then you're going to take detailed photographs of any individual stains that are used for point or of convergence, area of origin, or that show critical characteristics. And then you're going to use the road mapping technique and obtain serology and DNA samples from every significant pattern. So road mapping is essentially you identifying all of the patterns that are present on scene. So if we have that expectorate, we have that impact pattern, we have that cast off pattern, when I'm road mapping, I'm going to say, okay, this cast off pattern, this is stain A, this impact pattern, this is stain B, this is expectorate pattern, this is stain C, but you might see multiple cast off patterns. So you'll have to identify all of the cast off patterns that belong to one movement versus another movement versus another movement. If you see multiple impact stains, you'll have to be able to identify, okay, this is this impact spatter pattern versus over here, this is this blood stain, and these elliptical blood stains that I'm seeing, these belong to this impact spatter pattern. So now you might have A, B, C, D, E, F. So you're going to be road mapping all of the bloodstain patterns that belong to each individual single bloodstain, discrete bloodstain. And so from there, you're going to obtain serology and DNA samples from every significant pattern that you have identified in your road mapping. All right, so with that, that concludes everything about bloodstain pattern analysis and reconstruction for this lecture, and I hope you guys have a great week.